Hello, geometry friends. Quiz tomorrow, so this is our last review before the quiz. I'm not going to do everything with you. You guys have access to the answer keys, so you can do the work and then check the key. That's why I put those up there. That's my expectations, is you actually look at the answer key to make sure you're doing things correctly. If you're not practicing them correctly, you're setting yourself up to be unsuccessful. And I want you to be successful, but I'm not with you all the time. So use your answer keys to check your work. Try it yourself. Use the answer keys to make sure you're doing it correctly. All right. I do want to go through question number 2 with you because these are the harder types of questions that you may be faced with. And to be honest with you, I think these are kind of fun. So what I did is I made a picture for you to go along with the question. It says, in a new hockey video game created by Geometry Gaming Company, the programmers used a coordinate grid with a scale of 1 unit equals 10 feet to help the puck and player movement in the game. The center of the rink is the origin 0, 0, as you can see from the diagram. A player at position point -4, 3 shoots the puck and the goalie saves the shot. The puck was located at -8, 0 when the goalie catches it. How far did the puck travel? And don't forget the scale is 1 square equals 10 feet. So what do we know? Well, the player is at position point -4, 3. So that would convert into our real life units. Um, So if we were at the point -4, 3, that's going to convert to an actual location of -40, 30, dealing with our scale factor. And the puck was saved or caught by the goalie at -8, 0, which would translate into -80, 0. We want to know how far the puck traveled, so we will use our distance formula with those 2 points. So x2 minus x1 squared plus y2 minus y1 squared. Go ahead, get your calculator, push some buttons, and tell me how far the puck traveled. So after doing this calculation, you should have the square root of 2,500, which is 50 feet. Now, if you did the distance formula with the coordinate points first, you would end up with 5, and then you would multiply it times the scale factor of 10 to get the final answer of 50 feet. So it could go either way. Part B, write an equation that describes the path of the puck. So in order to write the equation, we need the slope and then a position point, so we can use point slope formula. Well, we have 2 different position points to choose from, so really what I have to do is just figure out my slope. So slope is y2 minus y1 over x2 minus x1. It doesn't matter if you do it in terms of the original points or the scaled points, because the scale factor will just divide out anyways. If we use the -40, 30, -80, 0 points, y2 minus y1 over x2 minus x1, we end up with -30 over -40, which reduces down to 3 over 4. If you use the original points, you would have gotten a 3 over 4 without having to reduce it. So now it says write the equation of the path of the puck. Depending on which point you use would depend on which equation your answer looks like, but we have a couple different options. You could also distribute, because it doesn't say it has to be in point slope form. So we could have gone over to the graph, plotted the point -4, 3, and the point -8, 0, and figured out that our slope is up 3 over 4, and then try to figure out our y-intercept from there. Or with the y-intercept not being a nice, neat, whole number, we could have, with our y-intercept not being a nice, neat, whole number, we could have used the other point. If we didn't use the point -4, 3, I could use the other point, the -8, 0, in which case the 0 really doesn't have to be written. So we could write it that way as well. All right, so we have two different options for how to write the equation of our line. And part C, if the puck took 0.4 seconds to get from the shooter to the goalie, find the speed of the puck in feet per second. Well, remember, we're going to use dirt. Distance equals rate times time. We've already figured out through the calculations that we did above that our distance is 50 feet. We are looking for the rate, and they told us the time was 0.4 seconds for the puck to travel from the shooter to the goalie. So divide both sides by 0.4. 50 divided by 0.4 is 125 feet per second is our rate. And here's what I really wanted to get to. Convert the speed of the puck from feet per second into miles per hour. Now, depending on your comfort level with conversions will depend on how difficult you think this is. So I'm going to show you how to do it so you can do this moving forward in any question that I may pose to you, because you'll have to do this in other questions moving forward in this unit. What do we know so far? Well, right now, with the calculation we just finished, we know that the puck is moving 125 feet for every 1 second. So now we need to figure out how many miles does it do in 1 hour. So a couple conversions you need to know. You need to know how many seconds are in an hour. So 125 feet is 1 second. So that would be 125 feet in how many seconds? So here's what you're going to do. Hopefully you were thinking about that. In order to convert into miles per hour, we have to convert our time into hours. There are 60 minutes in an hour and 60 seconds in a minute. So that means there are 3,600 seconds per hour. Okay, 60 minutes in an hour, 60 minutes per second. So 60 times 60 is 3,600 seconds in 1 hour. So next thing you need to know, we have to convert feet to miles. So how many feet in 1 mile? This is a standard unit of measure that you're kind of expected to know as far as the Board of Regents is concerned. You're supposed to know how many feet in a mile. Like you're supposed to know how many feet in a yard. If you don't know, I'm going to tell you. 5,280 feet equals 1 mile. Now, if you're at home and you're doing homework, you can always just go to Google and just ask to convert feet to miles. Okay, so here's what we have. We have 125 feet in 1 second. And we have to convert our feet into miles. So we're going to do our feet divided by 5,280. This will help us convert how many feet or how many miles we have for the hockey puck to travel. So we are going to take our distance of 125 feet, divide it by 5,280 feet per mile, and we get 0.0 2, 3, 6, 7, 4, 2, 4, 2, 4 miles. So 125 feet is 0.0236742424 miles. We need miles per hour. So miles per hour takes our miles 0, 2, 3, 6, 7, 4, 2, 4, 2, 4 miles for every 3,600 seconds, which means for every hour. And we end up with 85.227272727. So 2,273 miles per hour. And that's pretty standard for a hockey puck off a good slap shot. Can travel from 85 up to 90 miles an hour. That's legit. I looked it up. That's pretty fast. Okay, so that may have been confusing, but I'll walk through it real quick again. We have 125 feet for every 1 second. So what we had to do was take our distance of 125 feet, divide it by 5,280. That way we converted our feet into miles. Then multiply it times 3,600 to convert our seconds into hours. All right. All right. Part E, player 3 is located at -1, -2, and at 1 second, I'm sorry, player 3 is located at -1, -2 at 1 second, and then is at 7.4 at 3 seconds. How fast is player 3 skating in feet per second? Okay, so let's remember our scale factor, okay, because we need to do distance again, but we want to do distance with the correct numbers. So -1, -2 actually translates into the point -10, -20. And then 7.4 technically translates into the point 70, 40. So we're going to do the distance between those 2 points. You guys know the distance formula. So x2 minus x1 squared plus y2 minus y1 squared. So you're going to do the subtraction first. Square the number seconds. Add them together third. Hopefully you're doing this yourself. We end up with 1,000 feet. Now, the question asks, how fast is this player going? So he traveled 100 feet from 1 second to 3 seconds. That's 2 seconds worth of time. So he traveled 100 feet in 2 seconds, which means he traveled 50 feet in 1 second. So this player is traveling 50 feet per second. Pretty quick. Find the location of player 3 at t equals 0 seconds. Now we have to work backwards and figure out the original starting position of player number 3. This is very similar to the robot thing we did. And actually we did two different robot questions dealing with this kind of scenario. All right, so remember, the first thing we need to do is find the change in x and change in y. We're going to work with our horizontal component separate from our vertical component. So for our change in x, we're not going to undo the scale factor because we're looking for the coordinate point on our scaled down picture to see where this hockey player started. So we don't have to worry about the scale factor of 10. But x2 minus x1 is a horizontal change of 8 units. And then that 8 units occurred over 2 seconds worth of time. So this hockey player is moving 4 feet per second horizontally. And this hockey player started at an x coordinate of -1, subtracting out 1 second's worth of location because we know that at 1 second, after 1 second, he's at an x coordinate of -1. So I only have to subtract 1 second's worth of time, 1 second's worth of distance. So his x coordinate position point is -5. Now we have to go through and do the same process with our y values. So we're going to find the change in y, which is y2 minus y1. So a vertical change of 6 units. We're going to take our change in distance divided by our change in time, so we can figure out how fast this hockey player is moving every 1 second. And then work backwards to figure out where this hockey player started 1 second before our information was given. Then we can write our final position point to -5, -5. That was the starting location of player 3. Okay, well done. Thank you for listening, playing along, and paying attention. To go do the rest of the review, get yourself ready for tomorrow's quiz, and talk to you soon.